Hi, in this video we're going to use trigonometry twice in order to find an unknown angle in a right angle triangle. Now we've got these two triangles here, this one and this one. They're both right angle, which is great because we can use trigonometry, and they have this shared length in the middle. Now we're trying to find this angle y here, which is unknown, but we can't use this triangle immediately because all we've got is this one side length. That's not enough information to find out the angle. However, we do have enough information in this left triangle here to find, say, that shared length between these two triangles, because we've got the angle and the side. Now, let's concentrate on that triangle first then. We've got the 8, we've got the 37 degrees, and we want to find this length, because if we know that length, we can then use it in this triangle. Now, we don't know that length, so let's just call it x, and let's just draw out this triangle separately. 37 degrees, that's 8 centimeters, and that's x. Remember, we label the sides relative to this angle of interest. So this side here is opposite the angle, so it's called the opposite. We put an O, and this side here is next to or adjacent to this angle of interest, so we call it the adjacent. And we didn't use it, but if we had this side involved, that's the longest side of the triangle. We always call the hypotenuse, or H for short. So remember how we used SOHCAHTOA in the previous videos? SOHCAHTOA. Well, we're involving O and A here. O and A is here, isn't it? So we're going to use this one here. And remember, this was short for tan of theta, the angle of interest, is equal to O over A. So let's just substitute in to this. We've got tan of, well, the angle of interest, I said, is the theta. So this is the theta here. So it's tan of 37 degrees is equal to O, which is x, over A, which is 8. Now, I want to get x on its own. It's been divided by 8. So to get rid of the divide by 8, you times both sides of the equation by 8. And you get x over here equals 8 lots of tan 37. And if we do that on our calculator, 8 tan 37 is equal to 6.0284. I'm putting lots of decimal places because I don't want to have any rounding errors. I only want to round at the end. So I can round a bit, but just not too much. I'm going to put 4 decimal places. So this length here of x, I'm now going to put as 6.02843. Now we've got enough to use this triangle on the right. So we're trying to find this angle y. So let's just draw that triangle separately. So we've got the 9 at the top, and we've got this angle y, and we've got the side on the length, the side length on the left, which is 6.0284. Again, let's label our sides relative to this angle of interest. Well, the 9 is adjacent to, next to this angle of interest, so that's the adjacent, and this side here is opposite the angle, so that's an O for opposite. Now, it's going to be tan again because we've got the O and the A. So we've got tan of the angle of interest, y, is equal to O over A, which is 9. Now, we want to find y here, but there's a tan in front of it. To get rid of the tan, we saw earlier that you just do inverse tan. So inverse tan is just something that undoes the tan to get rid of it. So inverse tan, you write it like this, tan with a little -1. And then the inverse tan cancels out the tan, leaving y, and we're going to do inverse tan of 6.0284 over 9. So we just do that on our calculator. Shift tan, or your calculator might work different. Shift tan to get inverse tan of, and then I can do the fraction key. I'm going to use the answer key to put the 6.0284 from earlier over 9, press equals, and that gives me 33.8 degrees. Now I can round it because I want the answer to 1 decimal place. So 33.8 degrees is the final answer.